Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be talking about the topic organic chemistry. And we are going to continue with alkanes, and today we are going to be talking about isomerism. So we are going to look at how we form isomers of alkanes, and then we are going to do a few practice isomers with some of the members of the group. So isomerism is a situation where two or more compounds have similar molecular formula but different structural formula. So such compounds that have similar molecular formula but different structural formulas are usually called isomers. And compounds with the same molecular formula but different structural formula have different physical and chemical properties. Although they have similar molecular formula, you notice that their physical properties and chemical properties may not be the same. The first three alkanes do not form isomers. Isomers are named by the UPAC naming. We already talked about naming of alkanes. So we are going to be forming isomers and also naming those isomers that we form along the way. So let's start with butane. So if you are given such a question in the exam and you're asked to draw the isomers of butane and maybe it's not drawn, actually the first thing you draw is butane itself. Butane comes from 4 carbons. So when we are forming isomers, we usually form isomers by getting an alkyl group and attaching it to the carbon that is not the terminal carbon. So we will take this CH3 at the end. We can take even the one that is on the other side. So we are going to move this CH3 at this carbon that is at the center. So we cannot move it in any of the carbons that are at the end. We only move it at the center because if we move on the carbons that are at the end, it means that we are going to be repeating ourselves. So we put it at the center. So the new isomer will look like this. So remember the first compound is butane. After we move the alkyl group, this becomes 2-methyl propane. I know the names may sound different, but remember this is an isomer of butane. The reason why we said isomers have the same molecular formula but different structural formula. If you count the number of carbon atoms and hydrogen atoms, so we have 4 carbon atoms and 6, 7, 8, 9, 10 hydrogen atoms in this case. If you count the number of carbon atoms, it's similar here in the same case. So you see, if we were to draw the molecular formula, it will be C4H10, and this will be also C4H10. So it's the same molecular formula, the only difference is their structures look different. So butane has one isomer and it's called 2-methyl propane. Let's look at pentane. So we'll draw pentane with 5 carbons. So we input the hydrogens. Once more, we move the CH3. So we can move it in any carbon that is at the center. We can move it in this carbon and this carbon. I would advise you to start with the carbon at the end. So you start with this carbon that is not the terminal carbon. So we are going to have 4 carbons with the CH3 here, the new CH3 we have moved, and then we put the hydrogens. And we will call it 2-methyl butane. So once again, you can move another CH3 you can move it now into the same carbon. As you can see, you can't move it in this carbon or this other end carbon because you notice that it's going to be repeating itself. So this new isomer will have three carbons, the initial CH3 that we add and the new CH3 that we are putting. You remember we are not going to put any CH3 in these terminal carbons because we said that we are going to repeat ourselves because it will still be in the longest chain. So we put the hydrogens, and we will call this 2, there's no comma, dimethyl propane. So it has two isomers, 2-methylbutane and 2,2-dimethyl propane. Let's go to hexane. So hexane has 6 carbons. So we put the hydrogens. So we move this CH3. We said we put it at the carbon that is close to the end one. So we put in this one and it's going to have 5 carbons. And we have put it in this carbon. This is where we brought the CH3. So we put the hydrogens. And this will be 2-methyl pentane. We can form another isomer from this. So you move this CH3 as well. You can put it in the same carbon, or we can put it in this other carbon. So you have 4 carbons. We have a CH3 here. We can put the CH3 on top here. And then remember we have said it's possible, so we can go slowly and just put it there first. So this will be 2,2-dimethyl butane. And finally we can move this, let's see if we can get another one. You can't move again. But if you go back to this, we can also move this to another position. So remember this CH3, we said we can put it in this carbon or we can put it in this third carbon here. So if we move it in this third carbon, it's going to look like this. This is the initial CH3. We can move it here or on top. It doesn't really make a difference. It's still in the same position. So you see this one gives birth to this and also to this. So it can go either way. So this will give us 2,3-dimethyl butane. So that has 3 isomers. And then we go to heptane, that is 7 carbons. So we put the hydrogens. So we can move this CH3 and you can put it, now we move it to this carbon. So we have 6 carbons and the CH3 will come here. And then we can move another CH3 and we can place it in this carbon. So first of all, before we move, this is called 2-methyl hexane. So if we move the carbon, as we have said, we put it in this carbon number 3, we will have 5 carbons. We have a CH3 here and a CH3 here. So this will be 2,3-dimethyl pentane. We can move another CH3. This CH3 now we can move it either in these 2 carbons. You can put it in carbon number 2 or carbon number 3 to give birth to. So there's a CH3 here, another CH3 here, and a CH3 here. So this will be 2, 2, 3 trimethyl butane. And remember, we said this one can give rise to this one, and then this one gives rise to this, but also this one can be put in another way. So instead of us putting this CH3, we can put it on top here, such that this CH3 goes on top of the carbon where we already have a CH3. So we have with 5 carbon. So this is what I'm meaning. So this is the CH3 we have. So instead we put it here instead of placing it in this carbon. So we have an hydrogen, 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 and hydrogen. So this becomes 2,2-dimethyl pentane. After that, we do not have any other, we'll just be repeating ourselves. So those are the isomers of octane. You can go and try the isomers of the other ones. You can try octane and nonane or decane. You can try and see if you can both write those isomers. So this brings us to the end. So in the next lesson, we are going to be looking at the sources of alkanes and also later on look at how they are prepared in the lab. So see you then.